Hello and welcome to episode 5 in our Yocto Project Customization 101 tutorial series. I'm John Weber. In this final episode, I'll be showing you how to optimize your images. This is a long one, so let's dive right in. So what does optimization mean? Well, it usually means a couple things, either reducing the image size or in some other way increasing the image speed. In Linux systems, a popular optimization topic is boot time. However, for this episode, I'm going to focus on image size and save boot time reduction for another tutorial because honestly, boot time optimization could probably fill an entire tutorial series all on its own. So why would you want to have smaller image size? After all, flash sizes are going up with the advent of 3D NAND, triple level cell, and quad level cell memory have caused a huge reduction in non-volatile storage costs. There are a few reasons, however. First, initial programming of your image into the unit during production takes time, and that does mean cost. Second, even though storage is relatively cheap in dollars per gigabyte sense, by using a smaller amount of storage, you can use smaller devices to save cost. Next, something to think about is firmware updates. Over the air, or OTA, firmware updates usually have two components of cost. One is storage, which is the overall size of the update, and the other component is networking cost. Cloud vendors like Amazon do charge based on the amount of data transferred into and out of their servers, and by reducing your image size, you can reduce both the storage cost and the networking cost to reduce the overall cost to update or roll out firmware to all of your devices. So what do we mean about reducing image size? Well, even though Yocto is a way to build a custom Linux distribution, a lot of the time you're starting using an available image type. For example, in the last video, we built our images based on core image base, which is a standard image that is supposed to be a functional embedded Linux image, but without a lot of extra fluff. So what we're going to do in this video is show you some tools and things to be able to first see what is going into your images in terms of the packages and package groups, etc. And then to show you how to trim out packages, image features, and other files that are not needed by your application. So let's take a look at the image size, the Scorpion image as a baseline. Projects, Yocto, Zeus, next, build Xwayland temp, deploy images, Scorpion. All right, so let's do an ls-al on the star.ext4 files. So these are the rootfs file system images. So let's go ahead and look at this. So Scorpion image Scorpion is about 873 megabytes large, which is not a huge image by any stretch of the imagination. It's not huge, especially when you compare it to Ubuntu or to Android or something else. It's a lot bigger, a lot more functional. It's not very big, but still 873 megabytes is a lot bigger than you would think an image needs to be that effectively just runs a video console. So I think there's probably some ways that we can optimize this. And this is based on the Scorpion image recipe that we made in episode 4. The task of this particular tutorial in the series is to create a much smaller or slimmer version of this. So we're going to go ahead and do that now. One of the key ways of understanding what goes into your images is to turn on something called build history. So to do this, we need to go ahead and Yocto, Zeus next. Oh, CD. Let's go ahead. Let's go back home. Okay. Now, I mentioned before, what we need to be able to do is to understand what packages are being installed into the image. And the easiest way to do that would be to use build history. The build history feature, what that does is it creates a nice summary of what is being installed into an image, even broken down by package, and creates a package list sorted by size, which can be very, very helpful, and it can control all of that with Git. So you have a history of what the images contain. So all we need to do to be able to enable this is to be able to edit local.conf. So I'm going to go ahead and edit that. So vi build xwayland conf local.conf. And I'm going to go ahead and add a couple of lines here. I'm just going to go ahead and copy and paste these in here, and then I'll explain what they mean. So the first line here basically turns on the build history feature for the build system. The second line here, it tells the system that it should commit the build history and control the build history using a Git repository. And what makes that special and helpful is that after you run successive builds, you can see what the changes are between one build and another just by browsing the Git logs. That is a especially useful feature to be able to have. So we're going to go ahead and run a Scorpion image now. We're going to go ahead and build that. So I need to go ahead and set up my build system. / setup environment build. And I'm going to get bitbake scorpion -image. All right, and we're going to go ahead and fast forward through this because, as you probably know by now, building images takes a bit of time. See you in a few minutes. All right, so our build is done, and it just occurred to me that probably I wasn't very clear earlier on why we were doing that build of Scorpion image. After all, we've built that image before. It should already be there. The file system files that you saw there were already there. They're already, 873 megabytes. The reason why we did that is because we had just turned on build history, and we needed to go ahead and write that build history so that we would have the data that we need to start optimization process. So let's go ahead and browse that build history. So after you turn this on, what you will see in your build directory is this build history directory. So we can go ahead and look in that. And we have subdirectories here, images and packages. And what we're interested in is optimizing images. So we're going to go into the images directory, and we're going to go into the Scorpion directory. That's our machine. And then to glibc, and then into the Scorpion image directory. This is pertaining to the Scorpion image that we've just built. So just look here, and let's just run through some of these files real quick. At the very top, you're going to see the depends.dot file, and then all these other dot files. So what these are dependency graphs. You can use utilities like GraphViz to actually visualize these graphically, but because these are so big, and there are a lot of different interrelated dependencies, they can be very difficult to browse in a graphical manner. What I find more useful is just browsing them with a text editor like VI, because it's actually really easy to see the information that you need to see in terms of dependencies if you're looking for particular packages. So we're going to go ahead and use that. Then we're also going to look at the image info file. That is a summary file of what goes into the image, and there's also an overall image size in this file, which is also very useful. In the installed package sizes file, this is a sorted list of installed packages with their sizes in descending order. So very useful for looking at the packages that are largest, which always appear at the top. This installed package names is a list of packages installed by alphabetical order. So these files are the ones that are the most interesting. So let's go ahead and look at the image info.txt file. You can see here that we have a lot of different image information. This is the distro, this is the version of the distro. Of course, we're using Zeus. And then we have image classes, image features. They could mention debug tweaks, Splash, and the SSH server drop error. These are packages or image features that we added in the episode 4. And then in image install, we see a bunch of different packages that are added via the image install list, including all the different package groups. So one of the most interesting pieces of information here is the image size, which you can see here is, if you round up, it's about 656 megabytes. What you saw before was the ext4 file system size. This is the size of just the data files in this image without any additional empty storage space that has been entered into the image automatically. So this is the number that we want to reduce when we're talking about image size reduction. Next thing we want to do is we want to look at the installed package sizes, because this is ultimately where we're going to start our reduction. We're going to look at the sort of the largest files first. Okay, so immediately what you can see here are that we have some files that are fairly big, or these are packages, actually, they're very big. So what you're seeing here is the size of the package in kilobytes. This is 40,819 kilobytes. That's GCC, the GNU compiler collection. We have the libc6, the debug versions of libc6, and then we have Valgrind, which is a memory profiling and leak detection tool. The C compiler, there's a bunch of stuff in here. In addition, there's glmark2, and I don't remember us bringing glmark2 into this image when we built the Scorpion image for production. We don't have any test tools or anything like that brought in, so I'm just kind of curious how that gets in there. Let's see if there's any other stuff in here that doesn't look like it should be in production image. The GTK3 demo, don't know why that's in there. LM Bench, that's it. Stress NG. So anyway, we want to go through this. We want to see, okay, how we get some of these things that probably don't belong in a production image out, especially when we don't understand how they got in there in the first place. So for that, the best thing to do is to go look in the dependency graph. So I can go ahead and VI the depends.dot file. At the very top of the depends.dot file, what you're seeing here, you'll see basically three columns. You'll see this. This is the package, an arrow, and these are packages that are dependencies of this package. So we see that acl-dev depends on ACL, attr-dev, bash-dev, coreutils-dev, and all these other files. So if I'm looking for GLmark2, I can go in here and I can see these are different packages that are dependencies of GLmark2. So if you're bringing in GLmark2, you have to bring all these packages in as well. But let's go and see what, okay, this package depends on GLmark2. So this package group is what is bringing in GLmark2. Let's see if there's any other ones. GLmark2, there's another package that depends on GLmark2. This is thermal IMX test. So it looks like a bunch of utilities that are necessary to run a thermal test. So this is interesting. So why would we want to have this in a production image? We probably don't. So this is a good candidate for us to go ahead and get rid of it. What else is dependent on this thermal IMX test? All right. Okay, so thermal IMX test is being brought in. It's a dependency of package group TN tools. So what is this? Well, TN, I can tell you, stands for TechNexion. This is a standard package group that we bring in, but it's not brought in at the image level. It's actually brought in somewhere else. So we're going to go ahead and show you how you can search through and figure that out. So we're going to get out of this, and we want to be able to get rid of package group TN tools from our image. So this is our build directory, by the way. I should say our build shell. So we want to keep this where we can just run bitbake. And I'm going to go ahead and start a new terminal here. We're going to do some browsing around the metadata because we want to figure out how package group TN tools is ending up in our images when it's not any of the image recipes that we've defined. We're going to go to sources, and then we're going to go into the meta TN IMX BSP directory because we know that's where these things come in. I mean, this is a TechNexion recipe or TechNexion package group. It's probably in here. So we're just going to go ahead and grep for package group -TN tools in this directory and see what we can find. Okay, so we see a list of different hits that grep found, and immediately we know we can just kind of exclude some of this because we're not building any of these image recipes. This is interesting. So we want to take a look at this TN-base, and this is in the machine configuration section. So we vi conf machine tn-base.inc. And we see, look here, looks like package group TN tools is being brought into the image install list using the image install _ append. That's probably how it's getting into our image. But the question is, why? This is an include file that's used in machine configuration. If you remember correctly, what we did when we created the machine for Metascorpion, for the Scorpion image, what we did is we copied the Pico IMX8M Mini machine. So let's just take a look and say vi scorpion.conf. And there's why. Look, conf machine tn-base inc. So that's how that package group TN tools is getting into our image. So we can go ahead and take that out. Now, one way to take that out would be we could basically bring in tn-base, maybe rename it and include that here, but that's a lot of redundancy that you don't necessarily have to manage yourself. A better idea would be just to get rid of what you don't need, and we can do that fairly simply because we know that this was being included using the image install list, and we can actually change that in our image recipe. So we're going to go to our image recipe. So we're in Metascorpion here, already. So we can go into Metascorpion recipes, Scorpion images, and I'm going to go ahead and ls here. So you can see we have our 2 images that we made in episode 4. And I think what we're going to do is we're going to go ahead and create a minimal version of this Scorpion image recipe. And that's where we're going to do our modifications. CP scorpion-image.bb. So now we have that. So I'm going to go ahead and vi scorpion-image-minimal.bb, and I'm going to change the description here. I'm minimal. And so this is what we had before in the other image. So the way that we can go ahead and remove members of the image install list in our image file is we can go through and just do this, image_install_remove. Make sure I spelled that correctly. Install_remove plus equal, and then we want to get rid of that package group, right? So package group -tn-tools. Okay, and just a note here, whenever you're creating these lists, it's a good idea to put a space here between the first quotation mark and the backslash here. The reason why you do that is just to add some additional space, so that when these lists are formed, you have space in between the members of the list. So we're going to go ahead and just quit out of that. And we're going to go back to our build directory, and we're going to go ahead and bake that minimal image, Scorpion image-minimal. There we go. But we're going to do after we're going to come back from this build is we're going to browse the build history, and we're going to see what the impact was of removing those tools from the image. So stay tuned. All right, so now that the first iteration of our minimal image has been built, let's go ahead and take a look at the build history for this image and for the original image. Now we can go ahead and do that by I'm going to go ahead and just create a new window, because I can just get to the build history that way. CD to build history, then ls, CD to images, and I think that it is Scorpion glibc. And then now you'll see we have 2 different directories here, and these each pertain to the image name. So in this case, it's Scorpion image was the earlier one that we had done, the first one, and now this is Scorpion image minimal. So what we want to do is we want to take a look at both of the image info files in each one of those. So I'm going to go ahead and just start up another console port here, vi scorpion image/image-info.txt. So this is the original one. We could see that it was about 656 megabytes, and I'm going to vi scorpion image-minimal image-info.txt, and oh, okay, look at this. This is 524 megabytes. That is, if I'm doing the math correctly, a little bit over 130 megabytes, which is pretty good. So we know that the size of the package group TN tools is about 130 megabytes large. So the other thing just to kind of note here is that this is the list of packages in the image install list. So this is the minimal image, and then this is the image that we started out with. And you can see here that the the package group TN tools is in here, right there. And then that is not in this particular list. So yeah, some savings there. But let's see if we can do a little bit better. So let's go and take a look at the image recipe again, and look at Scorpion image minimal. Remember when we looked at the dependencies of the Scorpion image? Let me go bring up the minimal image again. Scorpion image-minimal, vi depends.dot. Actually, no. I'm going to do vi the package sizes. So installed package-sizes.txt. You can still see we have a lot of fairly sizable packages, but we don't need GCC, we don't need CPP, we don't need some of these compiling tools that honestly you don't really want to have in a production image. So how can we go ahead and get rid of those? Well, we know that we can actually go through the dependencies again, but we know how GCC and CPP have been brought in. So I can go ahead and look at the dependencies again though. So vi depends.dot. Next thing I'll do is I'll look for GCC. So that's not GCC, that's live GCC. Okay, so GCC has a bunch of dependencies itself. Oh, I might have missed one. Hold on. All right, let's be smart about this then. Let's do this. I'll do arrow space GCC. There we go. So this is what we expected to find. Then let's see if there's anything else. Okay, so what we found here is that package group core build essential, which is what we brought in when we brought it in here. This is the Scorpion minimal image that we brought in because we were also bringing in Python 3, this big Python 3 package. And that build essential is there to allow compiling of source code on the target. Obviously not something you want to do in production images because it could potentially be a security problem. but we want to go ahead, we can go ahead and get rid of this build essential, and it's just pretty much easy to do. Just delete that line. The other thing is that we know that Python 3 is going to take quite a bit of space. So if I look at that, I'm going to just go Python 3, it can get a little bit big. So we can leave this in, we can take it out. Let's go ahead and for this, let's go ahead and leave it in. We'll see what we get when we just remove the build essential tools. By doing this though, it's going to limit the ability for pip to install and compile packages from source. But this is just to see how things work out. So hold on. All right, now we're going to go ahead and rebuild the image. And then after that's done, we're going to go ahead and check the build history again. So stay tuned. Okay, so now we are done with that. We should have an image now without the built-in compilers on board or in the target image. So let's go ahead and check the build history of the minimal image. So I'll go to this particular window. And the right way to do this, since we have the Git capability enabled within Yocto or within Open Embedded, the way the build history is being modified is it's actually being checked into a Git repository. To be able to look at the differences between the previous image and the current image, all we need to do is browse the Git logs. So we can do that fairly easily. Git log -p -- and what I'm interested is the image info file. I want to see the difference between the previous image and the new image here, and this should be able to tell us that. So what we're seeing here is the commit message. It has a lot of information in it regarding the metadata versions, but now we're seeing the differences between the old commit and the new commit. So what we see right now is that the image install changed. So instead of including package group core build essential, doesn't include that anymore. And then we're going to see the difference in the image sizes. So now we have a image that is roughly, well, a little bit less than 100 megabytes smaller than the image with the compilers, etc. included. So that's a pretty substantial savings in image size. So this is pretty good. But that shows you how you can browse that with the Git log, which is kind of cool. With that, I think I'm going to go ahead and wrap this episode up. So again, my main goal for this episode was to show you some ways that you can A, understand what is going into your image, and B, understand why certain packages are ending up there, and finally, C, a couple of different ways to remove them from your image recipe so that you can end up with a leaner, more manageable image for production. There's certainly a lot more to cover when it comes to Yocto customization, and these last 5 episodes are really to help newcomers to Yocto project development start to navigate the somewhat esoteric and steep learning curve that I struggled with myself when I started learning it several years ago. I hope that I was successful in this regard. I look forward to bringing you more tutorials regarding Yocto and embedded Linux development in the future on our YouTube channel, so please subscribe. Thanks again for your attention. I'm John Weber. See you next time.